In the Working with Data chapter, I showed you how to allow users to post data to controller actions and then save that data to a database. In this chapter, I'll show you how you can protect your site by making sure that all of that data is actually coming from the users that you expect. The first step to locking down your site is surprisingly simple. Just place a single attribute named authorize on the controller actions that you wish to restrict access to, and then those controller actions will no longer be available to users who haven't authorized themselves as being able to access them. To see this attribute in action, let's see what happens when I put it on the create controller actions that I created a few videos back. Now, this attribute is in the Microsoft.ASP.NET.Authorization namespace, so you'll have to be sure to import that namespace in order to use it. With these attributes in place, let's try and run the site and navigate to these controller actions. The result is pretty unexciting. We see a blank page. However, if you open up the developer tools using F12 in most browsers, select the Network tab, and then refresh the page, you'll see that what we're actually getting is a 401 unauthorized result, meaning that our authorize attribute is actually working. It's denying access to this action because we are not logged into the system. In the next video, I'll show you how to use ASP.NET's identity services to enable users to register and log into the site so that they can gain access to these secured controller actions. In the previous video, I showed you how to secure controller actions by placing the authorize attribute on them. In this video, I'll show you how to use Microsoft's identity services to allow users to register an account with your site and log in order to access these secured controller actions. Like most features in this course, the first thing we'll need to do in order to begin working with identity services is to add a reference to this package in the project.json file. We can do this by searching for the keyword identity. Then, since we're using the entity framework for data access in our application, we'll choose the entity framework flavor of the identity services framework by selecting the Microsoft.ASP.NET.Identity.Entity framework package. ASP.NET's identity services are an object-oriented API around standard authentication and authorization techniques. And the entity framework implementation of the identity services is based around a class named Identity User. This class defines a number of common and useful properties to help define your users. Properties to store their email address, phone number, failed login attempts, and of course, their username and password. And since it's entity framework, it also requires a DB context class to interact with the database in order to save and retrieve user information. Not just any data context class, mind you, but a special generic type of DB context named Identity DB Context of type T, where T is any type that derives from the Identity User class. Now, I could just modify my existing blog data context to derive from Identity DB context instead of just plain old DB context. In fact, that would work absolutely fine. But I prefer to keep things separate, so I'll create another data context class just for identity, and I'll create it in a new folder under my models folder called Identity. Note that the name of this folder doesn't matter at all. You may place identity model classes wherever you like, including an entirely separate project. Once I've created my folder, I'll create a new class called Identity Data Context. And I'll have it derived from the Identity DB Context of type T base class. And now the question is, what generic type am I going to use here as type T? I could use Identity User directly, but that wouldn't really leave me with many options. What if I wanted to add a custom property to my users table, for example? So instead, I'll create a new class in the same folder named Application User. And then I'll have this new class derived from Identity User. And with that in place, I can go back to the Identity Data Context and use this as my generic type parameter for this class. Note that unlike the properties on my blog data context class, I don't have to specify a property to represent my users table because the Identity DB Context base class already does that for me. I can see this by using F12 in Visual Studio to drill down into the definition of the Identity DB Context class until I get to this definition, where you can see that it defines a handful of identity-based properties such as users, roles, claims, etc. I will, however, have to provide this data context with a connection string to tell it how to connect to the database, just like I had to do with the blog data context. However, this time I'm not going to hard code the connection string. Instead, I'm going to use the configuration API that I demonstrated a few videos back to make sure that I can change the connection string depending on the environment I'm in. Other than the missing connection string, that's all I need to do in order to define the classes I'll need. In the next video, I'll show you how to configure that connection string and wire everything up so that other classes and even ASP.NET itself can leverage these new identity services. In the previous video, I showed you how to add the identity services libraries to your application and create the custom classes that are required to use identity services with a database defined with Entity Framework. In this video, I'll show you how to properly configure everything so that you can begin using identity services to manage authentication and authorization throughout your application. Like all of the configuration I've shown so far, we'll wire everything up in our startup class. And I'll start by adding a call to app.useIdentity, which will register the identity services middleware to the ASP.NET pipeline so that it automatically authenticates a logged in user and populates the user's roles for each request. Be sure to add this before any other middleware so that the whole pipeline can take advantage of the identity services. With that in place, I'll jump up to the configure services method so that we can tell the dependency injection framework all about our new classes that we created in the previous video. First, register the identity data context class as a scoped instance, just like I showed previously when I registered the blog data context class. Then I can configure the connection string on the identity data context through a couple of calls, starting out with services.addEntityFramework. On top of that, I'll tack on a call to add SQL Server to indicate that I want to configure a SQL Server-based data context. And finally, I'll call addDBContext, which references my identity data context, and I'll pass in a configuration function that tells Entity Framework how to configure any new instance of that context. Inside of this configuration method, we'll call a special helper method on the configuration object, useSQLServer, in order to define the connection string for the data context. Now, this method expects a string containing the connection string value, so I'll just create a variable to hold that connection string. Note that the useSQLServer helper method is part of the Microsoft.data.entity namespace, so go ahead and import that namespace in order to access it. Here I'm using the connection string that points to the database named ASP.NET-blog_identity on the local DB instance on my local machine. And since that database doesn't exist, I'll actually have to tell identity data context to make sure the database is created in the class's constructor. Again, just like I did with the blog data context. Now that I've given the dependency injection framework everything it needs in order to create a new instance of the data context, I'll head back to the startup class and configure the identity services runtime itself with a single call to services.addIdentity. Now this call requires two generic parameters. The first parameter is the type that defines the user object, and the second parameter is the type that defines the user's role object. For the user type, I'll use the application user class that I created in the previous video. And since I don't need to customize the user role, I'll just use identity services built-in type for the role, identity role. This class is in the Microsoft.ASP.NET.identity.entity-framework namespace, so be sure to import that namespace as well. Once I've defined the generic parameters, I'll tack on one more call to this method, which tells identity services to use an entity framework data context to retrieve and persist identity data. This method also requires a generic parameter, which is just simply the data context type, in our case, identity data context. Now that we have all of that in place, we can finally begin using identity services. Head on to the next video where I'll show you how to use identity services to allow users to create new accounts in your application. In the previous few videos, I showed you how to add identity services to your application. And in this video, I'm going to show you how to start using those services to allow users to register themselves with your site. In order to allow users to post their registration information to the site, I'm going to start with a basic model, view, and controller, just like I've shown in previous videos. And since I've already shown all this, I've gone ahead and added them to the application already. Just so you know what's going on, I'll walk you through these files real quickly before moving on to start working with identity services. First, I created a model named Register View Model in a new folder named Account. This class represents the registration information that a new user will have to provide, properties such as email address and password. Then I use the register view model to create a strongly typed view with an HTML form for users to enter their information. I called this view register.cshtml, and I put it in the views account folder, which is actually the same name as the new controller that I made named account controller. In this controller, I started making the controller actions to display the view and accept the form post data as a controller action parameter. I know I just went through all of that very quickly, but if there's anything about what I just showed that you weren't able to understand, please go back to the Working with Data chapter, in which I explain all of these parts in detail. With all of that in place, I can pick up where I left off in the account controller and create the new user. And to do that, I'm going to rely on a great utility that Identity Services provides called User Manager. As its name implies, this class will help me to add the new user to our database. In order to use the helper, I need to inject a reference to it in my controller's constructor. Then I'll jump back to my register method and ask the helper to asynchronously create the new user in the database for me with a call to its createAsync method. Here I'll pass in the new user object that I want to create along with the password that they've entered. If this fails, I'll just add an error to the model state so that it gets displayed to the user and then return them right back to the view to try again. When it succeeds, however, go ahead and redirect the user to the login page so that they can log in with their brand new account. If you're confused about where this login page exists, that's because I haven't created it yet. In this video, I showed you how to leverage the Identity Services User Manager Helper class along with standard views and controllers to allow users to register a new account on your site. As it stands, once they've created that new user, they are redirected to the login page, which of course won't work because we haven't created the login action yet. But guess what? That's exactly what I'll show you how to do in the very next video. In the previous video, I showed you how to use the Identity Services User Manager Helper class to add new users to your application. In this video, I'm going to show you how to use another helper that Identity Services provides to allow those users to log into your site. And just like in the previous video, I've already created a model, view, and controller actions for users to enter their login information. First, there's the model, which I've called Login View Model and put in the Models Account folder. If it looks a lot like the Register View Model from the previous video, that's because I just copied the Register View Model and changed its name, and then added this Remember Me property. Here's a hint, I did the same thing with the view I'm about to show you as well. And here's the view, where users can submit their username and password to be validated. Note the link to the register action that we created in the previous video, where users can register a new account. And finally, back to the account controller, to which I've added a pair of login methods and a logout method for users to log out. The Identity Services Helper class I'm going to use to authenticate the user is called Sign In Manager, and in order to leverage it in the login method, I'll need an instance of it. So just as I did with the User Manager class in the previous video, I'm going to add the class as a constructor parameter so ASP.NET injects it for me. Then I'll save it as a field on the controller for use in the controller action. With the reference to the sign-in manager, I can go back to the login action and call the signinmanager.passwordSignInAsync method to attempt to validate the user with their username and password as credentials. First, I'll pass in the email address, which we're using as the username, then the password, then a Remember Me flag to tell the sign-in manager whether or not to save the login as a cookie, and finally a flag to indicate whether or not the user should be locked out if they fail their password attempts. If this authentication fails, display an error to the user and show them the login view again. If the authentication succeeds, however, redirect the user to either the return URL that they requested or the application's homepage. And finally, we'll implement the logout controller action to allow users to log out of the site. This method is pretty straightforward. Just call the signout method on the sign-in manager helper to make sure the current user is signed out of the site. Then follow the same redirect logic as before. Perhaps the most interesting part of this method, other than the signout call, is the fact that this action is restricted to an HTTP post only. This is a common practice to avoid someone simply redirecting users to a logout page to log them out unexpectedly. And with that in place, that's it. We've implemented our user authentication. Now that we have all of the pieces in place, we can run through the whole process. Go and create a brand new user, then use that user to log into the application, and then log the user out again. But before we do that, let's make one quick change to add the login and logout links to our layout so that users are easily able to access these new pages that we've created. I'll start by adding a new block to the sidebar. Then inside of this block, I'll check to see if the current user is authenticated or not. If the user is not authenticated, let's just show them the link to the login page. Otherwise, if they are authenticated, generate a form that will post to the logout method to provide the user with a logout link. And now when we run the application, we should see our new links and be able to test our new registration and login workflow. Let's go ahead and try it out. Since I don't have any account yet, first I'll create a new account. That redirects me back to the login page. Now I can sign in with that account. Now we can see from the sidebar text that we're logged in as our new user. Then when we're ready, we can log out. Now that we've allowed users to log into our site, we've actually exposed ourselves to a couple of vulnerabilities. Most importantly, something called a cross-site request forgery. Once you're done playing around with logging in and logging out, move on to the next video where I'll show you how to protect your application from this vulnerability. In this chapter, I showed you how to secure your application so that only authenticated users may access it. And whenever you have portions of an application important enough that they need to be secured, you've now got to start considering attackers who will want to break through that security and access your application through nefarious means. There are many techniques that attackers use in order to gain access to sites, but perhaps the two most popular techniques are SQL injection and cross-site request forgery. Accordingly, the .NET Framework provides helpful utilities to help guard against both of these types of attacks. A SQL injection attack is simple enough to define, and even simpler to defend against. The attack takes advantage of sites that perform dynamic queries against their databases by simply passing in an input from the text fields as part of the SQL query. Knowing that, an attacker can quickly figure out the proper set of characters to send to terminate the query command and send down their own command, such as select all usernames and passwords or delete all customers. The antidote to this attack is to never trust any input into your system and always sanitize any values that come in from form fields or otherwise, stripping out potential invalid characters and only allowing characters that are known to be valid. Luckily for us, we don't have to worry as much about this because in pretty much all cases, Entity Framework automatically corrects the values that we pass in through the link queries we've used so far. You should still treat all of your form inputs with mistrust, however, which leads us to the next type of attack. Cross-site request forgery, also known as CSRF or CSRF. A CSRF attack describes the situation in which an attacker is able to get a hold of your legitimately authenticated session and start sending commands and submitting data with requests that identify as you. Perhaps the most popular implementation of this technique is for an attacker to create a page on their site that induces the user to submit a request to your site. This request is now sent to your application as the target user, but the attacker now has complete control over the content of that request. For instance, posting spam advertisements as comments on a blog post, or even worse, posting a change password request, which changes the user's password to something the attacker now has access to. Because cookie-based authentication is generally considered trustworthy, the CSRF attack is very difficult to guard against, especially when it comes to GET requests for authenticated content. However, it becomes far easier to avoid this type of attack when there are multiple requests and responses involved in a particular transaction, as is the case when performing a typical HTML form post transaction that I've shown several examples of in this course. For instance, the login page we just created in this chapter. In situations such as these, the server can include a user-specific token that only it understands as part of the form post payload to be returned. If the subsequent post data includes this token, then the server can better trust that the user is submitting the data in response to the form that the server rendered. If this token is missing or invalid, the server can safely reject the request since it can be confident that the request was created elsewhere or manipulated in some way. ASP.NET MVC implements this token in two parts. First, the framework provides the anti-forgery token HTML helper, which generates the token and adds it as a hidden field in your form. Note that in order for this to work, it needs to be inside of your form so that it gets submitted with the post data. Alternatively, you can add the ASP-anti-forgery tag helper to the form tag itself. Then you need to be able to validate the token when the form request comes in. For this, the ASP.NET MVC framework offers a simple attribute that you can place on any controller action: validate anti-forgery token. With this token in place, I can run the application and view the source of the login page to see the new token has been generated as a hidden field. Then, if I tamper with this token and submit the form, the server will reject the request and reply with an error. However, if I resubmit the form without messing around with the token, everything works great. And that is the basics of protecting against a cross-site request forgery attack. While leveraging Entity Framework or any other ORM and link queries to protect against SQL injection and implementing anti-forgery validation tokens to protect against CSRF attacks is a great first step, do not consider this all you need to do in order to maintain a completely secure site. Since there are many, many more attack vectors than just these two, securing your application is far more involved than simply applying these few framework helpers. I implore you to learn as much as you can about web application security as possible. For starters, check out the Foundations of Programming Web Security course and several other similar courses available here in the lynda.com online video training library. Once you're satisfied that your application is secure enough to expose to the world, head on to the next chapter where I'll show you a few different ways to deploy your application so the world can begin using it.